Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
We can, from the equation immediately preceding equation 3312, so we can say equation preceding equation 3312, we can say that the partial derivative of the magnitude of the magnetic field with respect to time would be equal to the angular velocity times the maximum and the maximum magnitude of the magnetic field. We can then relate the maximum magnitude of the magnetic field to the intensity. So this will be equal to the maximum electric field, or we can say simply E sub m divided by c. And this would be equal to the square root of 2 times c times mu naught times I, the intensity. So 2 times the speed of light times the magnetic permeability in a vacuum times the intensity. We're taking the square root and again dividing by c. We can then relate the intensity to the power and the distance r using equation 3327. So, and then we're going to relate the angular velocity to the wavelength. We know that the angular velocity would be equal to the wave number times the speed of light, which would be equal to 2 pi times the speed of light divided by lambda, the wavelength. So putting this, essentially substituting this all together, we find that the maximum change in the magnetic field with respect to time would be equal to the square root of 2 times mu naught multiplied by the power divided by 4 pi c. And then this would be multiplied by 2 pi c divided by lambda r. And we can then substitute, and we find that the partial derivative of the magnetic field with respect to time, max, would be equal to 3.44 times 10 to the sixth. And of course, the units would be Teslas per second. This would be our final answer. That is the end of the solution. Thank you for watching.